Hello, my name is Kelly Oding. I'm doing the lab today. This is going to be the interactive advanced concept presentation, clock reaction. Description: the iodine clock reaction is a classic example of chemical kinetics, which you can do at home. Use the following video as a guide. And then for this experiment, I'm going to be using hydrogen peroxide, vitamin C, cornstarch, and iodine. I'm going to be using a clock for 5-10 minutes presentation on what's occurring through my reaction. So, I'm going to go on and do an explanation of it before I do the steps. So, the clock reaction is a demonstration of a chemical reaction. This is when the hydrogen peroxide that we're going to be using, the potassium, vitamin C, and cornstarch, we're going to be mixing them together. We will see which reactions are going to catalyze when exposed to the iodine. So within the different ones, we're going to see that the hydrogen peroxide molecules are going to have a reaction with oxygen and water. The oxygen reacts with the vitamin C, and that's going to have a reaction to produce carbon dioxide. The carbon dioxide is going to react with the cornstarch, and you're going to see that it's going to be swelled. It's going to be kind of chunky. It's going to be kind of like a thick substance. It's going to be like chunky inside of it. You'll see little bubbles within it. It's going to be the oxygen. So as you're going to see through the reaction, it's going to be various different things that are going to happen. You will see that it will become thick. The oxygen is going to cause the substances to bubble. So this is going to gradually get bigger until the oxygen cannot have any entrapment. The clock reaction, it's going to take the amount of time it's used for the reaction. Alright, the step-by-step explanation. The clock reaction is a demonstration of a chemical reaction within the solutions that we already talked about. It's the amount of time required for the reaction to complete its consistency. So the first part you're going to see, as we talked about, we're going to mix them. I have 4 different cups of mason jars. As we go forward, the clock reaction is going to show us different variables within these substances. So we're going to be using our time clock for 5 to 10 minutes, and I have done this reaction. I have seen that it was proven to be true. So as we go through, we're going to see that the iodine is very dark, and when it is added to the vitamin C, the mixture is going to be mixed together in our mason jars because I don't have beakers. And we're going to see that they start reacting together. So within the iodine, when we mix it with the vitamin C, it's going to become acidic protons. It's I2 concentrated to I negative. The hydrogen peroxide is going to be mixed with the iodine. The acidic protons 2H plus is going to be into iodine with the water. And then we are going to see that our reaction is going to be complete. Vitamin C is going to run out. So within the iodine, it's going to become I2, I negative, I3. The starch is going to be the blue iodine and the starch complex. So the I2 builds up and can form the I3 starch complex. Okay, so now that we have that information, I'm going to see that the beakers are going to continuously change color. And yeah, so for my reaction, you can see in the bubbles that have formed, you're going to see that it is completely chunky. It bubbled until there was no more excess for it to bubble within the oxygen. We are going to see the iodine got really dark within this one. It might have been the cornstarch I had, it made it a little bit less blue. And then we also have this one as well, which is going to be the hydrogen peroxide, and this is hydrogen peroxide by itself. So my results have concluded that the substances are going to change over a period of time. So as we look at the reactions between them, if the time is adjusted, then we will see as time goes forward it is going to have an effect on the reaction. Yeah, so as we see, the iodine bubbles, it's going to cause different reactions within them, and the hydrogen peroxide bubbles as well. And yeah, so that is the rest of my video. Thank you.